To wrap up the topic of indices, we will now explain the negative and fractional indices rules. So the negative indices rule states that x to the power of minus n or x to the power of negative n equals 1 divided by x to the power of n. An example here is given. 2 to the power of negative 3 is the same as, if we apply this rule, you write 1 divided by 2 to the power of 3. Another example that we have of a rule is x to the power of 1 over n equals bracket square root of x close bracket to the power of n. So 16 to the power of 1 over 2 is the same as the square root of 16. You can write it as square root, and you write the 2 here to the power of 16. But usually it is hidden. The 2 is not written. Whereas if you have other roots, for example, the cube root, 1 over 3, then you write it. It's not omitted, it's always written. 3. This is the cube root of 16. And this should not be confused with 3 to the power of 16. These are totally different. So here the 3 is like embedded in the root itself, in the root sign, whereas here it is multiplied by the root, and both of them have different answers. These expressions have different answers. Now let's move on to the next important point, which is that if x is not equal to 0, then x to the power of 0 equals 1 for all set of real numbers. So this means that all numbers to the power of 0 will give you 1. All numbers. So 5 to the power of 0 equals 1, 100 to the power of 0 equals 1, 1 million to the power of 0 also equals 1. But note that 0 to the power of 0 is undefined. So 0 to the power of 0 is not 1. It's undefined. Now let's move on to the last part of this session, which is the exponential equations. An exponential equation is any equation that contains a variable with an exponent or a variable in an exponent. As an example, we have 2 to the power of x equals 32, 2 to the power of x equals 25. So when the bases are the same, the powers also are equal. So as you can see here, 2 to the power of x, this 32 is the same as 2 to the power of 5. So now, hence you can say that x equals 5 because the bases are the same. So if the bases are the same, then the exponents also have to be equal. If the bases are equal, the exponents have to be equal. To wrap up this session, I have tried yourself questions. I will help you with the second question, but if you want to try it yourself, you can pause the video, answer the question, and then come back to my explanation. So I'll answer just the second one to illustrate how the second rule works. Actually, I will also do the first one because the first one has to do with both of the rules, the negative indices rule and the square root rule. So this is the same as first you express this as 1 divided by x to the power of 2 over 3 using the negative indices rule, and then you can also express this as 1 divided by, you use the square root rule, the cube root or the root rule, because it can be cubed root or even the fourth root. So here the cube root of x squared. So this is the final answer, and for this 81 can be expressed in terms of 3 as 3 to the power of 4, because if you multiply 3 4 times it will give you 81. So 3 to the power of 4 x, you can write it this way, equals 27 is 3 to the power of 3. And then 4x minus 3. Now this can be expressed as 3 to the power of 4x equals 3 to the power of, if you open the bracket of the exponents, 3 multiplied by 4x is 12x minus 3 multiplied by 3. So 3 multiplies this and it also multiplies that. 3 times minus 3 is minus 9. Now, since the bases are the same, the exponents should also be equal. So 4x equals 12x minus 9. Now you can move 12x to the negative, to the right hand side, to the left hand side of the equation. It will be 4x minus 12x equals minus 9. 4x minus 8x is minus 8x equals minus 9. If you divide both sides by minus 8, divided by minus 8, x equals 9 over 8. So x equals 9 over 8.